So hello everybody. So this is my first meetup that I'm doing virtually. I guess it's the case for a lot of people as well. So yeah, today we're going to speak about. I'm going to speak about how actually we can monitor something like the COVID-19 outbreak using the Elasticsearch. So the main goal of this presentation is not to go into the numbers I'm going to show you. It is more about how actually we can just take an example like the outbreak and show you how we can actually take data, put them in Elasticsearch using using an ingest pipeline, and then create a dashboard on top of it. If at any point during the presentation you have any questions, please feel free to speak up, right? Like it is a regular meetup, so feel free to unmute yourself and ask a question, and I will be more than happy to answer any question you may have. So let me first let me close my Slack and my emails before I start receiving weird messages. And here we go. Okay, so first of all, let me introduce myself. My name is Melvyn Peignon. I'm a curriculum architect at Elastic. So what do I do? So I'm working at Elastic for 2.5 years now, and I'm developing content related to trainings. So meaning that I'm building training, for example, that then we deliver all over the world. So I used to be an instructor before I was an instructor for Elastic as well, delivering training in EMEA and APG mostly. So yeah, that's pretty much me. Before I was a data scientist, so I used to work a lot with data, analyzing them, and all these kind of things. So this is why I started working for Elastic in the first place, because I love data, and especially I love playing with data. So I really had a good first impression with Kibana, and I really love this product. So that's what this presentation is going to be about. Great. So just let me give you a bit of context. So when there was the outbreak about the coronavirus, what I use a lot these specific websites. So the Johns Hopkins Institution created this map, and they used it to display every case of the coronavirus that we detected all over the world. So I started looking at this map, I think I remember back in January. And at this time, like, I would say the disease hasn't spread as much as it is now. And I was very interested in the data. But there was a lot of frustration on my side because the map presents a lot of limitation. So for example, I'm French, as you can hear by my weird English accents. So I'm French, and I couldn't dive into the data. So for example, if I go back to the map here, you can see that there is a lot of cases, but you don't really know how many. So you can see on the table on the right, you can see how many cases there is in France, but you don't know how it evolved in time. There is a bunch of limitations, things that you cannot do. For example, I cannot select a part of the map and create a filter out of it. And I don't really like the map representation. The points are too big sometimes, and kind of doesn't carry a lot of meaning. So all this limitation make me thought like, okay, I could do better in Kibana, and why don't I try to do it? So I decided to make it more flexible. So I tried to find a data set, and I actually find it. I used a data set from the World Health Organization. So every day, the World Health Organization is releasing a PDF containing all the cases that happened during the previous day. So for example, at the end of the day, I think it's midnight, they publish a new PDF containing all the information. So I can show you that actually. So this is the Johns Hopkins map, right? Which is like you can see it, you can zoom on the map, you can see all those different tables, but as I said, like there is a lot of limitation to this map. So I decided to collect data, and I found this specific data set from the World Health Organization, and every single day you can actually retrieve one of the reports. If you click here, you can see that we have the PDF that kind of summarize how many cases happen, and with a specific number, how many people have, how many confirmed cases do we have, how many new cases do we have, how many people die, etc. If the transmission is local or if it was imported by another country, and so you have a lot of information in this daily report. So I was like, okay, I can use these data sets now. Let's have a look at the data. So from this PDF, I'm parsing it into a CSV. But when you are actually looking at the data more closely, then you can see that there is a lot of issues with the data directly. So if I'm looking at one sample, I mean there is two samples, but if I'm looking at two lines directly, I can see that one of them is presenting a value like mainland China. The problem with mainland China is that it's not a real country, right? It's not like mainland China is not official. So if I'm taking this value and then try to put it on a map, then it's not going to work because we'll not be able to know what mainland China is about. As a human, I know what mainland China I refer to. It means China, right? Excluding Taiwan. But of like a map will not be able to will not be as smart as I am. So mainland China need to be changed to something more common, like for example China. So if you want to know what are the different values that you need to have in order to represent your data in a map, you can use this specific site. So here I'm going to show you the website that host all our map layers, and you can see that here we have all the layers that we can use in our map application. So for example, here I was looking at China, for example. Let's see what the official name of China is. So there is multiple code for China. So you have the ISO code 3166, which is CN, right? Or the full name will be China, right? So you need to have at least one of these three values in your document in order to be able to display your document inside this specific shape on a map. So yeah, so I was facing this kind of issue. Another example will be the unassigned location. As you can see, that's not a country, right? I mean, like the country here is the US, which actually is a country. But if we are looking at the value before the country, it's actually I would say the region or the province. It can be a province. So for example, Hubei is a Chinese province, but this one is not a province, it's not a state, and we don't know what it is. It's actually a boat, like it's one of those cruise that happen in nearby Japan, where a bunch of people contracted the disease, right? So here we know it's an American citizen that is stuck on the boat. So here, again, like I'm facing a value that I can actually use to display it on a map. The good thing is on the right side, you can see that we actually have here sometimes some documents go along with geolocation, so latitude, longitude, that we can actually use to display on the map. So you see like all this data inconsistency kind of raise some kind of red flag. So I need to work on the consistency of the data before indexing them inside Elasticsearch in order to be able to leverage my data correctly inside Kibana. So what I've been doing is first I have my CSVs and I read the CSV file, process it with Python. So every day I have a cron job that is going to import the data from the CSV and send that to Elasticsearch. And I've been doing a lot of work inside Elasticsearch directly in what we call an ingest node. So inside this ingest node, I have defined what we call an ingest pipeline, and this ingest pipeline is going to transform my document. So for example, it's going to take continental China and transform it into China that we can then leverage inside the map application. And once I've been transforming all my document, I will be able to display them in Kibana directly. Does that make sense? Any questions so far?
No.
No? Okay, great, awesome. So let's move. I'm just going to move to a small demonstration. So let's go to Kibana here. Let's see. Let me open the chats. Yeah, I can highlight the Python code as well. The Python code is super simple, so like it's more about ingesting data. But yeah, I can show you the Python code. Here basically like it's importing the data. Then here I specify the URL for Elasticsearch. I'm specifying the where the data sits inside Elasticsearch, where is the instance. Here is my token. I will need to change it now. And then what I'm going to do is then I'm going to just define a bunch of functions that are actually going to read the file, eventually parse some data, change the dates, because like you know, sometimes like there is inconsistency with the dates that are present in the report. So what I'm actually doing is because like sometimes there is American format and then European formats, you know, where the position of the month on days are swapped. So basically I need to detect if it's an American date format or a European date format, and then put the date format in the correct way. So yeah, it's just basically reading the file and then put everything inside Elasticsearch. So that's basically like everything that the Python code is doing. So it's putting all the data inside Elasticsearch, and when doing so, it is going to go inside Elasticsearch in what we called an ingest pipeline. And I'm going to show you the ingest pipeline because it's actually the most interesting thing here, because this is what is going to transform the data. So an ingest pipeline is just a bunch of scripts, it's just a bunch of processors that your document is going to go through. And for every single processor, it's a transformation that we're going to apply on the document, right? So for example, here you can see that one of the processor here is, okay, well, if the number of death is higher than 0, and if the number of people that are sick is higher than 25, then I'm going to compute what we call the death rate. So I'm going to compute what is how many people die from the disease. And it's actually enriching my data with a new value now, because I will be able to know, okay, what is the death rate of the disease per country, right? So this processor is going to compute the death rate. And I will have, for example, another processor, which is going to transform, for example, the name of the country into meaningful values. So for example, if you see mainland China, then you need to create a new field called country ISO, which will be the an ISO format name of the country. So here, for example, China will be mapped as CN. And I will then enrich this specific document with, for example, the population of China, in order to have, for example, an example of what is the percentage of the population that is that has contracted the disease or not. So you can enrich your document using this specific ingest pipeline. So I've defined like a bunch of processors, so to transform the name of the country into an ISO, but as well I have defined one to change the name of the province into an ISO as well, or an American state into an ISO format value. And then I have created a bunch of visualization and I put them together. and I've created this specific dashboard that you can see here. So here you can see that you have the dashboard, and inside this specific dashboard, we have all the value. So I've created a bunch of visualization that kind of summarize how many people contracted the disease. So here is the number of people that are confirmed. Here's the number of total number of people that die from the disease, and here's the number of people that recover. And here you can see that I've put a map of the world. So now that all my values are actually in an ISO format, I can actually tag them and put them on a map. And since I, as well as geolocalization of some of the cases, I can actually add the geo information. So I took the time as well to break down some of the biggest country into areas. So for example, if you zoom to China, you're going to see that it's going to as well break it down per region, Chinese province. So for example, you can see that most of the cases in China are actually present in Wuhan, right? So which is where the disease was initially discovered. How complex is the Python code to take data and put it into Elasticsearch? So yeah, as I showed, like the code in Python is relatively simple. It's mostly reading a file and indexing the data into Elasticsearch, fairly simple. Most of the hard work, I would say, is done on the Elasticsearch in an ingest pipeline. So yeah, so if you zoom out, now we are going to go back to a world view, right? And we have the same behavior. For example, I have implemented the same behavior for the United States. If you zoom in the United States, you are going to have a breakdown by American states, where the disease actually is present. So so yeah, so this is this map represents the number of cases all over the world. This map represents the number of deaths all over the world, and then you can actually look at the evolution of the disease over time. So you can see that here we kind of reach some kind of plateau, but then it starts going up again, starting around approximately start of March. And here, this is a total new number of confirmed deaths. So how many people, how many new people, actually it's not the good name here, but it's actually the number of people, the number of new people contracting the disease. So here it's a cumulated sum, right? So meaning that in total you have almost 200,000 people that contracted the disease. This value is actually representing how many new people contracted the disease today. So here we know that yesterday actually we have 15,000 people that contracted the disease just yesterday. And this is a number of countries that contracted the disease, so more than 100. And then here below there's a summary of the data. Yeah, I hear a question or something. No. Okay, great. So remember, one of the main limitations that I was facing with the other map was the lack of options to drill down into a specific country. So what I wanted to do, for example, is I wanted to be able to say, okay, here we go with France. I'm going to apply the change. And now I'm just going to look at French data. So you can see that in France, we have like 8,000 people. We have 150 people that died. And this is how it evolved in France. So you can see that here, the growth is higher than actually the world growth. And this is like, for example, yesterday, we had 1,000 more people that contracted the disease. So now, like, this is a very interesting, for me, like it's a very interesting shape that your data are taking, because it shows like it kept growing, it's not going to stop soon. But like I'm wondering, like when I'm actually looking at the world data here, if you're looking at how does the world data look like, you can see that. Let me refresh the data. You can actually see that we kind of reach a plateau here, but it still grow way slower. So now, like most of the case here, like almost half of the case, total case, are coming from China. But if you look at China, which is very interesting. Oops, not friends. Like if you look at China, you're going to see that China already reached its plateau, right? There is almost no more new cases, but they have most of the cases that are already discovered. So now let's actually look at the world without China. So we can actually exclude China from a result set. And now we can see, so we are looking at everything but China. And you can see that actually, well, it's very similar to the French growth, right? Which is actually like, we don't have any plateau. The number of people getting sick keep increasing. So if you exclude China from your result sets, you exclude most of the cases, but as well, like since China successfully stopped the outbreak, you can see that now we're kind of in a phase of growth. Any questions? No, great. So I'm going to show you how I've created the maps, because like a lot of people are curious about this map aspect, and I think like maps is something extremely important in any kind of visualization. It gives you a good idea of it gives you a good idea of how does the disease, I mean, how does any data set look like, and it's more interactive for any user. When you have a map, it's always more fun. I think any data set is always more fun or interesting when you have a map. So let me show you how you can actually create a map visualization. Oops. So here I'm using an instance in the cloud. I'm using the European map. So my code is already on GitHub, but yeah, I can put it more generally available. But like as I said, like the dataset could even be imported directly as a CSV. So in Kibana, you have what we call the CSV import that you can use. This specific button, you can just drag and drop any CSV, and it's going to load your data inside Elasticsearch. So you can actually drag and drop a CSV file, and it's going to load inside Kibana. So it's fairly simple. What I've been doing, right? Like what I want to highlight is there was no, like it was not a hard task to do. I've done that in one day. Over a weekend. So it's not something that is very challenging. Yeah. So let me go back to the map application, and I'm going to show you how I can create oops, the right button. So a map is just a succession of layer, right? So you just put layer together, and then you can display one layer after the other. So for example, I'm going to create a map here, and what I'm going to do is initially you have only the roadmap layer. So for example, if you have like up to 24 zoom level. So for example, you can zoom, right? And you will see how precise is the map. So for example, this is Paris, and I actually can zoom on my home, like if you want, like I can zoom here. I'm living in Cergy, and you can see we can zoom up to 24. So the precision on the map is pretty good. So for example, this is where I'm living. I'm living on an island, and you can see my home will be over here, right? So I'm living here. So you can see that since this is a road map, you can see that you have the name of the streets. You have information about the specific, just like it's almost like Google Map at this point. Shows the name of the restaurant, the name of the bar nearby, etc. Yeah. So once we have this first layer, then we need to add other layers. So for example, let's say that I want to add a layer. I just press here, add layer, and then you have different kind of layers that you can add. You can, for example, add what we call the document. So here, by just selecting documents, you will be able to select which index pattern you want to use. So let's say, for example, I want to use my index pattern called coronavirus. And by selecting this index pattern, I will be able to see all the different dots that are present. So here I'm looking at the last 15 minutes of data. Let's increase it to, for example, the last, I don't know, last 48 hours. Should have more documents. Yeah, so you can see that now I'm displaying the last 48 hours of documents. And you can see every dot is actually one reported case that contain a latitude and longitude. So here you're going to have a latitude, and every dot is actually representing a specific case. So for example, we could change what the case is looking like. So for example, let me show you, once I'm satisfied with the layer, I can just decide to add the layer. And I will be able to define when is this layer visible. So here I'm saying, well, it's visible starting from the layer, from the zoom level 0. So when I'm not zooming on the map, right? So this is zoom 0, and then I can define when I want it to disappear. So here is going to always stay, even though I'm zooming on the map. So yeah, I can give this layer a name. So for example, I can say, well, this is case, reported case. So I'm defining a name, and then I can, for example, add other things, like for example, what do I want to display in the tooltip? Maybe I want to display, for example, let's say I can display the number of confirmed cases. So now if I'm going to this specific dot, I can see that for this specific area, there is 3 confirmed cases. And for example, for the United States, this specific dot here, or this one, I have 223 reported cases. So you can actually use this specific field to enrich, to add information to your tooltip. There is as well other things that you can do. You can eventually change what the icon is looking like. So by default, it's a dot, but you have many other options. So for example, maybe we can try to find something that is more relevant to a disease. So maybe something like, is there any good, yeah, let's for example across, right, or whatever. So there's a bunch of icons that you can use. You can as well define, for example, how big will be the icon based on some metrics. So for example, I could say, well, the symbol size will be based on a specific value, and maybe it can be based on the number of confirmed. So the more confirmed cases there is, the bigger the symbol will be, right? So you will be able to play around with that kind of I will say metrics. I could change, for example, the color. I could say, well, let's change it to some kind of a blue. So yeah, you have a lot of flexibility in how you can create your map. So once you are satisfied with the map, you can actually save and close the layer. And then eventually you can decide to add another layer. So for example, let's start adding, I want to represent like how many cases, how many, let's say how many, I want to see how the different countries are impacted by the disease. So I can select EMS boundaries, and I'm going to select, so I want to represent the world country, right? So I'm selecting this specific field, and I'm adding a layer. So by default, it's going to show me, okay, for every single country, it's going to show me the whole layer. So if I'm zooming out, you can see that every single country is actually colored. But now what I need to do is I need to define, okay, what will be the join between my layer and my document. And remember, I added this ISO information. So all I need to do is I need to say, well, I'm going to use the ISO code, 2-letter, and I'm going to use my coronavirus index pattern. And I've defined this field code country ISO that I can use, right? So now it's going to tell me, okay, this is all the countries that are actually inside Elasticsearch that have a good ISO, and then I can define what kind of metric I want to use. So here, by default, it's going to do a count. Let's say I want to do the maximum of the number of confirmed, right? And now I need to define that the color will be based on a specific value that I just defined here. So I'm going to say by values, and then I'm going to say it's a max number of coronavirus cases. And once I've been doing that, I will be able to change the color. So for example, I want to say it need to go from, well, because that's something bad, it need to go from yellow to red. And I would like, so it's, it's yellow. So if, for example, if a country is not, I will say, it's not very I can as well use this sigma value to work a little bit with the color to highlight, because for example, China will dominate way too much the color on the map. So I can actually use this sigma value to play around with, to linearize, I will say, my values on the map. So I can use this sigma value. And what else I can do is I can try to add another base layer to say, well, if you don't have any case, I want you to be green. And as you can see here, if I'm selecting this, it almost looks like countries that have a small value will be considered as a healthy, but that's not really the case, right? And countries that don't have any reported case, they will not be included. I mean, they will be white, which is not how I want to represent my data. So I'm going to keep my yellow to red colors, and then I'm going to add another layer, which will be this one. It's going to be same thing. It's going to be a country boundaries, and I'm going to take the world country, except that this world country, I'm going to keep it green, but then I'm going to move it at the bottom of my layers. So I'm going to first apply a green layer, and then I'm going to add on top of this green layer let's say my yellow to red layer, so this specific layer. And then what I want to do is I want to make the cross appear on top of my layer, so I can take one layer and move it up, and now you can see that my cross are now displayed correctly. Does that make sense? Any questions? So now if I'm closing this and this is how you can actually create a simple map in a few minutes. So now, so let's go back to the slide deck. So yeah, I've been doing that, and yeah, so if you want to learn more, everything I've shown you, as I told you, I work in the training team at Elastic. So everything that I showed you, we teach you how to do it in our training. What is important to understand, based on the situation with the coronavirus, is that we can deliver this training online if you're interested. So we are delivering like all this knowledge in multiple language. So if you're speaking English, Korean, Japanese, I can even deliver in French if you want. We deliver training in different languages across different time zones. I know this meetup is for APG, and I know APG is kind of big in terms of time zone. So if you're interested in knowing more how to use the stack and how you could, for example, create such a map, feel free to take one of these training or to ask me how this training works, and I will be able to answer any question you may have. On same thing, we have a subscription that you can do online. So do you have any question about what we just talked about? I will be able to answer any question you may have, hopefully, if they are not too hard. So yeah, for the ingest, I use I just use Python to put the data inside Elasticsearch. But yes, indeed, I could have used Logstash. But like what I wanted to do is I wanted to use the cloud, and we don't have Logstash in the cloud. So, and as I told you, I was a data scientist back in the day. So like I'm used to code things in Python. So for me, the fastest way was to do it in Python. But yeah, I could have read the file using Logstash and then add all the ingestion logic directly inside Logstash and say instead of Elasticsearch nodes. Can machine learning be used to predict the growth in this chart? So yeah, I think it could be used to do that. I didn't try to do it, but yeah, like normally for machine learning, you need around 2 weeks of data in terms of in order for the model to learn from the past and to be able to predict the future. So yeah, you could use a feature called forecasting to try to predict how big the number will be, like in let's say 2 weeks approximately. So normally we use machine learning for things like when will you not have this space anymore. But I think machine learning would be smart enough to be able to predict correctly how does the disease evolve. So yeah, you can already do that with the map. So if you click on France, you can then add a filter. I don't know, like I haven't tried to do it or I haven't demonstrated, but yeah, you can always, for example, click. For example, if I'm clicking here, let me try to click on France. So you could, for example, filter by geometry and add a filter. And now, like you can see here, we have a filters that's been created, and it's going to filter all my visualization in my dashboard based on the filters that I've just created. So you can use one of your shape to generate a filter on top of your map. This is the good things about map. It's fairly easy to create a filter using a map. So yeah. Did I answer your question, Yassine? I'm not sure. Like, so for example, if I go back to my dashboard here, let's leave it, and I can show you that once it's loaded. So let me remove this specific filter. So for example, here, I could just click here and filter by geometry, create filter, and you can see that all my visualization will actually be updated. Yeah, so here you can see that all my visualization are updated based on the values that I've selected, right? So like map are fairly intuitive in this way. Oh yeah, so for example, if I overlap, you can see that we have the So here, like if you are looking at the tooltip, so I configure the tooltip in order to display, for example, the ISO code, the name of the country, and the number of cases there is. And I think I've done the same thing here. Yeah, so here it's not going to display the ISO code nor the name of the country, but it's going to display the number of people that die because this map is representing how many people die. Can we change the growth chart axis to logarithmic to see if rate of growth is constant or changing? I don't think so. Let's see. I don't think we had this feature in the past. Maybe we have it now. So let me show you. I create this specific chart. So I'm going to create a vertical bar based on top of my coronavirus index. I'm going to select the last 60 days. And I'm going to show the max of confirmed. And on the y-axis, I want to display, let's say, a date histogram with a daily interval. So now let's try to go inside metric and axis. Can I do it? Log. This is a log you want, right? Up, let's try to see how does that work. And now I've applied the logarithm scale. I hope that answers your question, Scott. Can the basic license subscription create a dashboard you have created? Yeah, so the basic with the basic subscription, you can do whatever I showed you there. So all the visualization are part of even the open source distribution, but the map app is the only thing that is only present in basic. So the map app is actually what requires basic. And so this is part of basic and you can do everything with it. So yeah, you can do everything with the basic license. Everything I showed you, you can do it with the basic license. Yeah, if you are using the cloud, you have basic by default, so just go for the cloud. Is there a possibility to predict the number of deaths in a region-wise? So as I said, I didn't try it, but you could eventually create a machine learning job on top of your time series data, and eventually try to predict how many deaths there will be in the future. There is a job called forecasting, and this job is going to try to infer based on your past data how much, for example, death you are going to, or confirmed cases you are going to have in the future. So I will say it is possible. We can do it for things like this space because it's relatively predictable, and I believe like it will work for such a scenario as well. I didn't try it, to be honest. But I'm positive that it could work. Did I miss any question? I think so. Okay, great. Any other questions? Okay, great. Yeah, so I think if there is no more question, I don't know if Michael, you want to say something? Yeah, so thank you very much, everybody. I hope you enjoyed. The presentation. If you have any other question, feel free to reach out to us. You can reach out to me on Twitter or LinkedIn or whatever you want. But yeah, we're going to have more virtual meetups because of the situation. Yeah, hope you enjoyed it. Hope you enjoyed the presentation. I think it's always nice to take a topical subject in order to highlight how the product can work and everything you can do with the product. Yeah, thank you very much, everybody. And yeah, so we're going to split way. Bye, everybody.